Yep, so welcome to everybody to this workshop on tools for the energy sector. This is a workshop by XAIDA. If you don't know what XAIDA means, then this is the Extreme Events Artificial Intelligence for Detection and Attribution. And if you don't know what detection and attribution mean, then don't worry, that's the next slide. So the field of detection and attribution is relatively new. And the first papers came out in 2004, following a very extreme heat wave in Europe in 2003. And then the researchers needed to look at a large temporal season, so temporal period, so they used the whole of the summer, June, July, August, and they used very large areas in order to see a signal. But since then, yeah, unfortunately, the climate is warming, so that's introduced a stronger signal, but also our methods have been improving. So we're able to now go to smaller scales in time and in space. So a recent event which caught the attention of many is the Pacific Northwest heat wave, which shattered records on the daily timescale. And as with this event, as many others, the question pops up, what does climate change have to do with this? Can this event be attributed to climate change? And in detection attribution, that question is split into two parts. Firstly, are events like these changing in frequency or magnitude? And that is what we call the detection question, where we look to the observed world to see if we can detect a change in what's happened up until now in observations. So here you can see a time series of annual maximum T maximum temperatures. And there's a lot of natural variability on that signal, but still there is a signal that comes through that. And you can see right at the end is the extreme itself, which is way above that trend. But in what's happened up until now, there's still a contribution. And the question is that trend, which has contributed to this event, is that related to climate change or not? So we do that by looking at climate models where you can switch the effects of climate change on and off as a controlled experiment. You can also do that a little bit with observations by plotting them against the global mean surface temperature as a proxy for climate change, but you've only got one realization of the real world. And in models, of course, you can run them many times with slightly different conditions. This is an example of one model result, and you can see there's a lot more data, so you can get a much better signal to noise ratio or much better results. Often the uncertainty is reduced on your attribution result. If you can see that there's already agreements between observations and models, then you can you can reduce the uncertainty on those results. What we're doing in detection attribution is comparing today's climate with the past, but model simulations obviously can be run into the future, and you can use the same techniques to see if the assumptions are held, if they're kept, then what will happen in a future world compared to today's world or compared to the past. But that was a very simple approach to attribution, but there are challenges in attribution that we can't always tackle with that simple approach. One is the data quality and variability. We have many areas where there is poor or short data sets, or depending on the variable that you're looking at, there can be a lot of natural variability, which can impede detection, as you can see on the figure on the right. The red dots show time series where there's 50 years or more of data of precipitation from stations. And there's large areas of the world where that just isn't the case. So you might have shorter time series, but your results are not going to be robust. There are very rare or yet unseen events, as we've seen for the Pacific Northwest heat wave. And then you get an idea of what's been going on in the past, but very uncertain statistics on the return period and so on of the actual event itself. There's compound and cascading events, which stakeholders are extremely interested in, but there's no standard way to analyze those yet. Then there's a very large interest in having definitions relate to impacts. And we also want to be able to understand the physical processes which are going on. So XAIDA is hoping to answer some of these challenges, but what is XAIDA actually? The main overarching aim is to develop new artificial intelligence methods to study how global warming is affecting extreme weather worldwide. It's a 4-year EU-funded project, and we're over halfway through now. It unites 16 climate change institutes working within Europe, and we collaborate with a large range of stakeholders, and we will be developing new educational material together with teachers. So some XAIDA highlights that relate to those challenges. We are advancing the detection techniques for low resolution observational data, for example, for convective events where precipitation is very sporadic, and hurricanes. We've looked into unseen events and also no longer seen events, such as very cold winters that we'll come to later today. And that's been a focus in our cities workshop as well. Then we'll be looking at, we look at also compound events such as heat and drought, and very cold winters combined with wind drought, which is an interesting problem for the energy sector. And finding new impact-based and process-based event definitions, which we'll touch on in our agriculture and the legal workshop that we had earlier today. So for the rest of today, we'll have a couple of presentations, and the structure will be 5 minutes per presentation with about 10 minutes of questions following, and then we'll open up to more general questions. So that's also very welcome, and your feedback. So here are some questions to think about as our presenters are talking. Do you have any suggestions on how to make these methods more applicable to your needs? What do you need for this sector? What kind of requests do you get? And how useful would these methods be if they were operational? What do you think is currently lacking in what we've done so far? And what is needed? I'd also like to add that there was a talk on ensemble boosting given by Eric in the cities workshop, which may be of interest to you. And Eric's hoping to join 1 hour later into this workshop. So if you have questions on ensemble boosting, which is how to look into unseen events or very rare events, then he would welcome questions on that, and he may even have some slides to share if there's a moment spare.